This will be for the con exercise, period of sinusoidal functions from graph. So by definition, period is the distance between two consecutive maximum points or two consecutive minimum points. These distances must be equal. So you can't see it too well on this graph, but if this sine wave kept going in this direction right here, and it hit the maximum point, the period would be the distance from here to here. Okay, that would be the period. And I'll put in parentheses, basically for the sine wave, it's going to be the horizontal distance. All right, so you can see here it goes from a maximum to a maximum. And it doesn't always have to be from a maximum to a maximum. Okay, really, another definition of period, you can basically call it one cycle. All right, and they said max to max or min to min, but really it's just one cycle. So I can show you from a different perspective on this graph. If I start at the midline right here and I go through the maximum, then the midline again, then the minimum, then the midline again. Okay, this distance from here to here, and I'll do it in a different color, this distance from here to here is also the period. Okay, so you can think of it as one cycle. Okay, below is the graph of a trig function. It intersects its midline at these coordinates. Okay, and these coordinates are written on the graph. And it says, what is the period of the function? Give an exact value. All right, let's see. So the period of this function, they said it would be from a max to max, the distance. Okay, so we're basically looking at this distance right here. This would be the period. Okay, and the reason that's the case is because the graph runs through one cycle from here to here. See, it starts at a max, goes through the midline, and the minimum, midline again, and then max. Okay, if we drew this again, we would just be drawing the same thing again. So this is one cycle right here. Now, we can easily find the distance from here to here, but how much of the period would that distance be? Well, let's see. If we go, I'll do this in black here. If we go from here to here, this distance from left to right would be 1/4 of the period. And then when we go from here to here, this distance would be 1/4 of the period. And then from here to here, that would be another 1/4 of the period. We're looking at the left-right distance. And from here to here, that'd be another 1/4 of the period. All right, so see, we have 4/4 from here to here. From here to here is 1/4, and from here to here is also 1/4. Okay, so if we went from this point to this point right here, that would be half the period. So if we can find this distance, we can just multiply it by 2 and get the period. All right. So if we want to find the distance from here to here, we just need to take the difference of the x coordinates and take the absolute value. Okay, so for the x coordinates, I have -5/4 pi and I am going to subtract the other x coordinate, -7/4 pi. Okay, and if that is not a positive number, you just take the absolute value at the end. Okay, so the two negatives in a row make it positive. And we basically have positive 7/4 and negative 5/4. So 7 minus 5 is going to be 2. The common denominator is 4, and we still have pi. So that is only half the period. Okay, so we just have to multiply that number by 2. So the period is just going to be 2 times 2/4 pi. Okay, 2 times 2 is 4, divided by 4 is just 1, and we still have the pi. So the period is 1 pi, or just pi. So in the box, you can click pi, or you can just type pi, and it'll give you the pi symbol. So if I could show you their answer, okay, their solution, if you'll notice, when they go from the midline to the maximum, that distance right there is 1/4 of the period. And then when they go from the maximum to the midline again, that distance is also 1/4 of the period. And then when they go from the midline down here to the minimum, that distance is 1/4 the period. And finally, when they go from the minimum back to the midline, that distance is 1/4 the period. Okay, so one cycle, this whole thing here is one period. So it goes up, down, and return to the midline. See, that is one full period. That's 4/4. So in our problem, we were limited. If I could bring it up again here. We were limited. We only went from midline to minimum to midline. Okay, so that was only half of a cycle. That's why we multiplied it by 2. All right, below is the trig function, intersects its midline at these coordinates. Midline at this one, and minimum point is this one, okay? The write-up doesn't matter much. You can see the coordinates on the graph. What is the period of the function? Okay, so once again, here's a max. Go down to the min, here's a max. Okay, so this whole thing up here would be the period. Now, I'll do it in a different color. If we went from here to here, from maximum to minimum, that would only be half of the period. Okay, and then if we went from here to here, that would be another half of the period. But that's not what we have here. We only have the distance from here to here. Okay, and that horizontal distance from here to here, that is only 1/4 of the period. You see, we are going from the minimum to the midline. Okay, if we went from min to max, if we went from here to here, that would be half the period. But this distance right here is only 1/4. So if we just find this distance and multiply it by 4, we have our period. All right. So we're looking at x coordinates. If we want to find the distance from here to here, we're just looking at x coordinates. So I'm going to subtract 5.2 minus 1.2. Okay, 5.2 minus 1.2. And that is just 4. Okay, I don't need the absolute value. It's already positive. So this distance here is 4, but that is only 1/4 of the whole period. So I just multiply the 4 by 4. Okay, because this is only 1/4 of the period. So the period is going to be 4 times 4, which is 16 units. All right, this one did not have any pi on the x coordinate. Okay, so it's just 16 units without the pi. All right, so for the trig function, they give us the maximum point and the minimum point. They give us the coordinates. They're right on the graph. What is the period of the function? Okay, so again, if we went from max to max, that distance right there would be the period. All right, but we don't have that. We are just going from this one here to this one right here. All right, we're going from max to minimum. So this right here is only going to be half the period because we went from maximum to minimum. All right, we went from max through the midline to the minimum. So if we find this distance and multiply it by 2, we'll have the whole period. All right, we're just looking at x coordinates. We have -5 minus -1.7. And of course, you take the absolute value. 2 negatives make it positive. Positive 1.7 minus 5 is going to be -3.3. Okay, but then you take the absolute value, and it's positive 3.3. All right, again, if you don't like absolute value, you can always put the larger number first when you subtract, and you won't have to do that. Anyhow, we said that is half of the period. Okay, that's only half. We need the whole thing, so we just multiply that by 2. So the period is just going to be 2 times 3.3, which is 6.6. All right, so right in the box. Again, there was no pi on these coordinates, so it's just 6.6. All right, last one. Midline is this coordinate here. And again, the other midline point is right there. Okay, so let's see. The period would be from here to here. This whole thing would be the period. Okay, but this piece here from here to here, that would be 1/4. And this piece from here to here would be 1/4. From this point to this point would be 1/4. And this point to this point would be 1/4. So if we go from here to here, we have 1/4 and 1/4. So that distance right there is just half of the period. All right, so if we find this distance here, we can just multiply it by 2. All right, so let's see. We're looking at x coordinates. All right, so 7/5 pi minus 3/5 pi. Okay, I put the bigger number first, so I don't need absolute value. We have a common denominator. 7 minus 3 is 4. The common denominator is 5, and we still have pi. Now, we said this was half, so we have to multiply this by 2. So the period is going to be 2 times 4/5 pi. Okay, 2 is a numerator, so 2 times 4 is 8, divided by 5, and times pi. 8/5 pi. So in the box, I type 8/5, hit the right arrow key, and you can click pi, or you can type pi, 8/5 pi. By the way, pi out front like that is the same as if the pi were in the numerator next to the 8. So 8 pi over 5, that's the same thing.